Now let us discuss about analytical treatment of the full wave rectifier. Let instantaneous value of AC voltage applied across the terminal AK is EAK equals to E naught sin omega t, and that across the terminal BK is EBK equals to minus E naught sin omega t, where omega is the angular frequency of the AC voltage. Let when the diode is forward biased, the resistance of the diode is Rf, and when it is reverse biased, the resistance is infinity. Let I1 and I2 are the instantaneous current through diode D1 and D2. So I1 equals to Im sin omega t for the time interval 0 to t upon 2, and I1 equals to 0 for the time interval t upon 2 to t, and the current I2 equals to 0 for the time interval 0 to t upon 2, and I2 equals to minus Im sin omega t for the time interval t upon 2 to t. Here Im equals to E naught upon Rf plus RL. Hence current through load resistance I equals to I1 plus I2 equals to Im sin omega t for the time interval 0 to t upon 2, and I equals to minus Im sin omega t for the time interval t upon 2 to t. The voltage drop across load resistance is V equals to I into RL equals to Em sin omega t for the time interval 0 to t upon 2, and V equals to minus Em sin omega t for the time interval t upon 2 to t, where Em equals to RL E naught upon Rf plus RL. The output of the full wave rectifier is continuous but fluctuating DC. The fluctuating DC consists of sum of pure DC and AC of different harmonics. Hence, by using the Fourier series, the output current I can be written as I equals to IDC plus sum over n equals to 1 to infinity Is sin n omega t plus sum over n equals to 1 to infinity Ic cos n omega t. By using the Fourier transforms, we may solve for the values of IDC, Is and Ic. On solving, we get I equals to 2Im upon pi, which is the DC part, minus sum over n equals to all even numbers up to infinity 4Im upon n square minus 1 into pi cos n omega t, which are different AC harmonics. Now let us calculate average value of output current. The average value of the current is IDC equals to 1 upon t integration from 0 to t IDT equals to 1 upon t integration from 0 to t upon 2 IDT plus integration from t upon 2 to t IDT equals to 1 upon t integration from 0 to t upon 2 Im sin omega t dt plus integration from t upon 2 to t minus Im sin omega t dt. So IDC equals to 2Im upon pi. Now let us calculate RMS value of output current. The RMS value of the current is the root of the mean of the square of the current. IR equals to under root 1 upon t integration from 0 to t I square dt equals to under root 1 upon t integration from 0 to t upon 2 I square dt plus integration from t upon 2 to t I square dt equals to under root 1 upon t integration from 0 to t upon 2 Im square sin square omega t dt plus integration from t upon 2 to t Im square sin square omega t dt. By solving, we will get IR equals to Im upon root 2. Now let us calculate RMS value of AC component of current in output current. We know that IR square equals to IDC square plus IAC square. So IAC square equals to IR square minus IDC square. On substituting the values of IR and IDC, we get IDC equals to Im under root 1 upon 2 minus 1 upon pi square. So IDC equals to Im under root pi square minus 8 upon 2 pi square. Now let us calculate ripple factor. The ripple factor of rectifier is defined as the ratio of AC component to DC component of current. So gamma equals to IAC upon IDC equals to under root IR square minus IDC square upon IDC. So gamma equals to under root IR square upon IDC square minus 1. On solving we will get gamma equals to 0.48. Now let us calculate efficiency of full wave rectifier. Output DC power PDC equals to IDC square into RL equals to 2Im upon pi whole square into RL. Input AC power PAC equals to IR square into RF plus RL equals to Im upon root 2 whole square into RF plus RL. So efficiency eta equals to PDC upon PAC equals to 8 upon pi square RL upon RF plus RL. For ideal PN junction, RF equals to 0. So eta equals to 8 upon pi square, nearly equals to 0.812. So efficiency eta equals to 81.2%.